Hello friends, welcome back. In this video we are going to discuss about Spark SQL in a Spark. Spark SQL is the API which is provided by the Spark itself to deal with the structural kind of data. So initially what was happening when we want to do any kind of the work which is similar to the SQL, like select star from table name. So for that we need to write the big Java code or the Scala code. So just to override these kind of things, they have come up with the Spark SQL concept, which is pretty much simple, and we can deal with the structural kind of data very easily. So we have the requirement here that we are going to take the data as a CSV file format. So let me put it in the PowerPoint so that you can understand in the better way. Before starting to this video, let me spoke about please subscribe to this channel so that I can put more and more videos in the future which is related to the Hadoop, Oracle database administration, SQL and the cloud. This will help me to grow up this YouTube channel. So without wasting our time, let us start. Let us assume that we have a file. It's a CSV file which is available on the local file system. It's a local file system. You can also consider as a HDFS file system. So I will just tell you about the difference between how we can write when the file is on the HDFS file system or when the file is on the local file system. At this point we are doing it on the local file system. So we are going to load the data from the CSV, and then by using the Spark SQL we are going to fire some command on this data. So we have a data available here in the CSV file, and we are going to fire some SQL command with the help of Spark SQL. So this is how our requirement is, and let us see how we can do it. The Spark shell is already open here, and this is a file is available in F directory, F location, F, and the file name is customer.csv. Let me open this file here. So this is the data. Here we do have 13 records, and the first is the header. This is the data of all employee along with their designation and the details, other details. Our requirement is we are going to pull all those records which is having the employee number greater than 7788. So it should fetch all those records like this. So first of all we are going to load this CSV file in the Spark shell which is available in the F directory. Then we are going to apply a Spark SQL APIs, and further that once we have a Spark SQL APIs available, we can perform a SQL query on the top of it. Let us see in the practical way. So val path equals to, first of all I am going to load customer.csv file in the variable path. Here you can see we have loaded the path. Next we are going to create another variable employee df. Df is a data frame. So spark.read.format csv option header equals to true dot load path. So if you see here properly, we are going to load a format CSV file, and header we have mentioned as a true. It means it will print the header as well, and load path which is replacing with the variable path here, path hadoop, and this is the location. Actually the thing which needs to be see here carefully, that the time when we are loading the CSV file, it is returning a data frame. So the data frame is ready, and the data frame name is employee.df.csv. so by using the spark.read.format and in the bracket CSV, we can load the CSV file. This is probably a most interview asked question. They are asking that how we can load the CSV file and the JSON file in Spark 2.0. so this is the Spark 2.0 version. We can say by using the command spark.read.csv. also you can mention I have already created the video and you might have seen in the other playlist how we can load the CSV file and the JSON file. I have already described in another videos, and it is returning a data frame, not RDD. This is one important thing, because most of the times they are also expecting from us that we should be clear that it is returning a data frame. Here you can see, if you want to print the schema, we can use dataframe.print schema. So all those record has been loaded to this employee DF data frame and along with the schema. So this is the schema we have. Schema is ready. Now we just need to use a SQL command. For that we have the command dataframe.create or replace view. So in order to perform a SQL, we need a table, right? So for that we need to register one table. So at this point we are going to create a temporary view, and the temporary view name is employee, and on the top of employee we are going to select the data. Okay, so create or replace view, and then we are going to use spark.sql. Spark object is already created the time when we have opened the Spark shell, and this is the employee. Here please be reminded that this is the temporary view what we have created. Done. We should get the data select star from employee where employee number is greater than 7788. Okay, this is what our requirement. And now by using the show method we can get the output. This is how we are getting the output. We are getting all those output whose employee number is greater than 7788. Okay, this is how you can use the Spark SQL in the Spark, and this is one of the most important and frequently asked interview question. So first of all we need to load the CSV file spark.read.csv. Next thing is, once the CSV file we have loaded, then we need to register a temporary view so that we can do our SQL kind of work on that table and on. So we have registered with the help of create or replace temporary view, and once it is done, by using the spark.sql API you can fire the query on the top of that temporary view. Okay, and if you want to write this content you can use spark.write and the location. At this point we have loaded all those data from the local file system. If you want SJPS, it should be loaded from the SJPS location. You just need to mention SJPS column double quotes and then path, so it will be pointing to the SJPS location. Thank you so much for watching this video. See you again with the next video. Please do subscribe and like this channel to get the more videos on the technology, Oracle DBA, Hadoop, SQL and cloud. Thank you.